So an absolute value graph, its parent function looks something like this. So if we're talking parent function, that means y is equal to the absolute value of x. All right. Now, if you did the delta math assignment, or at least started it, what did I say happens when you plug a number in for x? So, like for example, do some quick evaluations. What's the absolute value of 5? 5. What's the absolute value of 7? 7. What's the absolute value of negative 3? 3. What's the absolute value of negative 10? 10. So what does an absolute value do? Not mirrors. It makes it. So what happened for all these numbers? What's the outcome be? They're all what? They're all positive. All right. So absolute value, regardless of if it's originally positive or negative that you put into it, it's always going to be positive on the way out. Does anyone know why that is? It's actually in your delta map. Why is it that even though positive or negative, we get a positive out? So the true definition of absolute value, it's not just some random thing that some guy came up with. Absolute value actually is a math thing that describes the distance a number is from 0. All right. So, for example, let's say absolute value of negative 3. All right. How far away is negative 3 from 0? 3 units. All right. So that's why the absolute value of negative 3 is 3. What if I had 2? How far away is 2 from 0? 2. That's why the absolute value of 2 is 2. All right. So that's all that absolute value means. It just means the distance from 0. All right. Now, this stuff is more so just kind of getting you thinking about what absolute value actually does. So let's look at the graphic organizer first. And again, if you haven't already, highly recommend getting Desmos open. So when it comes to solving absolute value equations and inequalities, while there is a mathematical way to do it by hand, I more prefer if you can do it in Desmos. All right. Mainly because the method for doing it by hand, I will still show you how to do it by hand, but the method for doing it by hand can get a little confusing sometimes, especially once you get into the inequalities. But if you do it in Desmos, at least you can figure out what you're looking at. It's a lot easier. All right, so I'm going to show you both methods, but I'm going to do more heavily with Desmos. All right. Now, first thing that we're going to do is, given this graph, so there's going to be 2 graphs here. We're going to have y equals the absolute value of 2x minus 3 and y equals 5. And we're going to graph those two. Now, y equals 5, what type of graph would that look like? So y equals 5, what would the graph look like? It's a what? It's a horizontal line. All right, so we can go ahead and draw that one because that's easy. So we're going to draw this line right here. Now, as for the absolute value, we're going to make a table first, but we're going to use Desmos to help us make that table. All right. So we're going to go to Desmos. All right. And I'm going to type in that equation. So y equals, and as I'm doing this, you guys should be doing this too. Absolute value, you have to go to your keyboard to get that. It should be towards the bottom. Absolute value of 2x minus 3. Now, does anyone remember how to generate a table in Desmos? So not one where you fill it on your own, but one where you can actually get all the values. I hit the what? Right, we hit the settings key, and then what do? Hit the little table. Now, the great thing is that we can type in any x value we want, and it'll give us the y value. All right. So take a minute. Using that table, fill in the table on your sheet with the given x values. So if there's any of them that are not on that current table, generate them. When you finish filling in your table, go ahead and graph that same graph up at the top graph. So use those points on that table, graph it on the graph. So once you get your points, graph it on your pink sheet. Thumbs up if you're ready. I'll give you another minute. So once you get those points, graph them on your pink sheet. All right. So there's the table. Here's what the numbers that should be on your table. Everyone good with the table? So if you graph that table, here's what the graph should look like. So this should be what you have on your sheet right now. the table, it should be 975311359, the odd numbers. Thumbs up if you're ready. Let me move on. All right, now why is this important? Why do I want you to graph it exactly? Well, because that's where the next part's going to come in. So, in Desmos, along with the absolute value graph, I also want you to graph that horizontal line, so y equals 5. Now, when it comes to solving equations, all right, you can solve basically any equation, regardless of whether it's absolute value, exponential, logarithmic, linear, quadratic, whatever. You can solve any equation in Desmos. All right. Now, if we look back at our sheet, here's the first question. What if we set the absolute value of 2x minus 3 equal to 5? So, how do you think I can use that graph to figure out what x is equal to? How can I use these two graphs that I just graphed to solve for x without actually having to do anything by hand? Look at the pieces. What's true about, what's the connection between the pieces in this function compared to what we just graphed? What are the two functions we graphed? So the absolute value is the same. So you graph the absolute value of 2x minus 3. They have the absolute value of 2x minus 3. What else is the same? What's it equal to? 5. Where did that 5 come from, you think? Where do you see another 5 with the graphs? Literally glaring at you in the face. Where is the other 5? So it's equal to 5. Where do we see another 5? Y equals 5. Now, here's my question. Y, what's another name for Y? So we talked about this before the snow. What's another name for Y? Say that one more time. F of x, that's another name for Y. What else is Y called in terms of a function? No, it's range, but it's not where I'm getting at. Think about what a function does. You put something in, you get something out. So input, output. Which one's Y? Input or output? Output. All right. Plug in something for X. That's the input. Get an output, which is 5. All right. So could we not say that if we say equal to 5, that's also Y equals 5? That's what we're looking for when Y is equal to 5. So if we're thinking about points, how would we figure out at what X values the Y values are going to be equal to 5? So if we're looking at the graph, how do I know which X values have a Y value that's equal to 5? Which points on the graph have an X value with a Y is equal to 5? So where is Y equal to 5? Where's Y equals 5? It's on this graph. So -1 and 4. Why'd you pick those? It's where this graph is crossing this other line. We already have Y equals 5. It's right here. It's this purple line that we already graphed. So we're looking for where they intersect. All right. So that's why using Desmos is great, because if you were to use Desmos, Desmos already plots the intersections for you. here, and here. Both of these points have the y value of a 5. So guess what? If I solve these equations, what do you think the x values would be? So if I solve that equation, absolute value 2x minus 3 is equal to 5, what do you think it will come out to be? What's the x values of the point? -1 and 4. That's the great thing about points, guys. Points have the input and output together. All right? So if you know what your output has to be, you can graph that. That's an equation of a line. And then you just find out where the two graphs intersect, and you use the x values as your answers. All right? So just to kind of reiterate what I said, this is the point -1, 5. This is the point 4, 5. Essentially what we did is we set both of the sides of the equation equal to y, and then we found the points of intersection. So in other words, where the two graphs crossed. That's how you can solve any equation, all right, using Desmos. So any equation I ever throw at you, whether it's absolute value, whatever, you can solve using Desmos. And remember, since we're solving for x, what do you think is the only part of the point I'm going to use? The x values. So -1 and 4, since we solve for x, that's the only things I got to do. So x is equal to the set of -1 and 4. Now, that's solving an equation. Pretty easy, right? Put it in, click where it intersects, boom, you got your answer. All right? Now, inequalities is a bit different. So, inequalities are intervals, like we've been doing with key features. All right? Your answers are not just going to be singular answers. So, definitively, if we plug -1 and 4 back in for x, we will absolutely get 5 if we did all the arithmetic. Inequalities, it's more so of, okay, what x values could I plug in that would give me any number less than or equal to 5? So it could give me 4, it could give me 3, it could give me 0, it could give me -1 billion. All right, as long as it's less than or equal to 5, it works. All right, so in other words, it's going to be a big range of numbers. Now, essentially, we're going to do the exact same thing. All right, so we're still going to use Desmos. So we're going to keep the y equals over here, but we're going to change where it says y equals 5 to be y is less than or equal to 5. So in Desmos, it's a very easy flip. Just go to this, and all I want you to do is change the sign. So you're going to change it to be y is less than or equal to 5. So when I changed the sign, what happened? So we still got the line y is equal to 5. That's still here, but what happened? It's shaded beneath it. Why do you think it's shaded beneath it? So if we're talking on a number line, what values of y are less than or equal to 5? So in other words, what numbers are less than or equal to 5? So just some numbers. What are some numbers that are less than 5? 2. What else? 3. What else? 4. What else? 1. All right. Isn't it true that those y values are all in the shaded area? Yes. That's why it's shaded beneath the line. It's showing us what y values are less than 5. Now, notice how the shading keeps going on forever and ever, and it is going to do that. It's going to go on to infinity. But we want the shading from where it's within our graph. So look at the red line, at least on my end. I don't know what color it is on yours. But if we look at the absolute value graph, which pieces of the graph do we want? That would give us x values. So in other words, what x values would give us y values that are less than or equal to 5? So in other words, you want to look where the shading is and where the shading overlaps with your graph. All right? So right here, these x values is where we want our graph to be. So in other words, if I drew lines here, do you see how the graph is in between these two lines? So any x value between these two lines has a y value that's going to be less than or equal to 5. What x values are these lines at? Negative 1 and 4. The same ones that we already found. We're still using the points that intersect. All right? But now we're looking at, okay, I want them to be less than. So if I shade underneath that 5, the only part of the graph that I use is this little bottom B part. All right? Now, would you say that these x values are between negative 1 and 4? Or are they like kind of going in different sides? Like one's less than negative 1, the other one's bigger than 4. So in other words, is the x values going on opposite directions of the two numbers, or are they in between the two numbers? They're in between. All right. So how do you think we would write that? So if I want my x values, so what we did is that we shaded beneath. All right. And we're looking at the x values right here, where our graph is between those two lines. So if we want to put this in words, we know it's going to be between x equals negative 1 and x equals 4. So it's between those two x values. But how would I write that in terms of an inequality? So think back to when you were doing intervals. All right. How would you say that it was between two numbers? Okay, so let's just say we were doing domain. Okay. And I said my domain is between negative 1 and 4. How would I write that with brackets or parentheses? First off, is it less than or equal to, or just less than? Less than or equal to. So do I use brackets or parentheses? Brackets. So what would it look like? Negative 1 to 4. Now, that's an interval notation, but typically if we're solving inequalities, I want an inequality notation. So, if it's between these two, that means I would have negative 1 on one side, 4 on the other. What would I put between them? Less than or equal signs. So we're saying that it can't be bigger than negative 1. Sorry, it can't be smaller than negative 1. And the x value can't be bigger than 4. It has to be between the two. That's what that means. So the way we would write our answer is our x value has to fall between negative 1 and 4. So this is what that means. all that means. So if it's literally between the two x values, you would write it always like this. The smallest number is less than or equal to x, which is less than or equal to 4. Any questions so far? Everyone like kind of, sort of? How you feeling about this? Now, greater than or equal to. So let's go back to Desmos. Now we have same absolute value function, but now it's going to be greater than 5. So again, we're going to keep the y equals of the absolute value function, but then we're going to rewrite this as y is greater than 5 in Desmos. So if I go back to Desmos, not that, I'm going to change that sign to be greater than 5. Now, if I change that sign, what happened to my shading? It went above the line. And does that make sense for it to go above the line? Yeah, because we're thinking number line, all the y values that are greater than 5 are up here. All right? Now, if we think back to our line, okay, typically whatever is equal to, that's what it's going to be between. Now, be careful with this because this is where it can get a little bit confusing. So, if you're looking at this graph, the red line specifically, don't just look at the shading. What side of -1 is this red line going to be in the shading? Is it going to be on the left side or the right? The left. So the graph's over here. So am I talking x values greater than -1 or less than -1? Less than. So x has to be less than -1. What about over here? So now we're at 4. Is the graph, so the red line, going to be in the shading on the left side of 4 or the right side of 4? The right side's right here. So would I say that those values are greater than 4 or less than 4? Greater. And guess what, guys? You just got your answer. So this is not a between. Why is this not a between? Why can I not say that it's between -1 and 4?
Because it's not inside the it's like outside.
Yeah, it's literally not in between the lines. We're going on the outside of them. All right? Between literally means between. All right? But since they're on the outer edges of these lines, they're going in opposite directions. All right? So we don't write this as what we call a compounded inequality, which is what we just wrote. We're going to write this as what we call an OR statement. So we're saying that x has to be less than -1 or x has to be greater than 4. Now, when it comes to OR statements, OR means at least one is true. Because can you think of a number, just off the top of your head, can you think of a number that is both less than -1 but greater than 4? Can you think of any number that's less than -1 and at the same time greater than 4? No, it's literally impossible. That's why we use OR statements. What we're saying is that as long as an x value is either less than -1 or it's greater than 4, it will make this statement, absolute value of 2x minus 3 is greater than 5, true. All right? So let's just do a quick check. So pick a number that's greater than 4. 6. All right? Let's just do a quick check. You don't need to write this down, but let's just see if I'm right. So I'm going to plug in 6 in for x. What's 2 times 6? Minus 3. 9. What's the absolute value of 9?
9.
Is 9 greater than 5?
Yes.
So that works. All right. So pick a number that's in between -1 and 4. Okay, 2. I'll plug in 2 in for x. What's 2 times 2?
4.
4 minus 3?
1.
Absolute value of 1
1.
is 1 greater than 5.
No.
No. So it can't be between -1 and 4, because if you pick the number that's in between -1 and 4, it doesn't work. But what does this number work for? So what does 2 work for? Doesn't it work for the one we did previously?
Oh,
Yeah. So that's what you can check for the one we did previously. We pick a number in between -1 and 4. That's 1 is in fact less than or equal to 5. All right. Now let's say we pick a number less than -1. So we'll pick a number less than -1. All right, -2. 2 times -2? -4. All right, what's -4 minus 3? -7. Absolute value of -7 is 7. Is 7 not in fact greater than 5? Yeah. So guys, this is a good way to check yourself. If you're not sure that you wrote the inequality correctly, just pick a number that actually falls in that range. All right. So, okay, I'm not sure if it's actually between -1 and 4. Let me just pick a random number in between -1 and 4. So you could pick 1, 0, 3, 2, whatever. Plug it in for x, see if you get a number that's less than or equal to 5. Same thing here. I don't know if I got the correct range. Pick the number that falls in it and check it. Okay? Does this make sense? So, these numbers are not just, oh, that's just because it fit in the shading. There's actually a reason behind it. If we actually plug in these numbers, we would get numbers either greater than or less than 5, depending on what we're shooting for. All right? So, it's all about where it falls in the shading. So, again, if I look back at the graph, the greater than is all on the outside of the lines, and it's going in different directions. So, in other words, it's all x values that are less than -1 and all x values that are greater than 4. That's where those graphs are. Whereas with the less than, it was between the two lines. Any questions so far? Now, this is just one example. I'm just showing you different ways that you can look at absolute value inequalities and equations. All right. Now, let me ask you guys to do this real quick. Little experiment before we move on. What if I made a tiny adjustment to the equation? So, all right, all I did was change the 5 to a -5. All right, so what I want you to do is, real quick, keep the y equals of the absolute value, but then change it to be y equals -5. And see what happens in your graph. Now, if I ask you to solve for x, with this one. So here's the line, y equals -5. Here's our original graph, absolute value graph. What's kind of the glaring problem here? They're not what? They don't intersect. These graphs, in no shape or form at any point in time, will ever intersect. All right. So what do you think my answer is? If they don't intersect at any x value, will those two graphs intersect? That's my question. No. So what do you think my answer is? No solution. Now, that is true for almost any negative number. Why do you think that's true? Why is it that if I do the absolute value of something and I set it equal to a negative number, I will always get no solution? Right, because anytime we do an absolute value, even if it is the absolute value of a negative number, we get a positive number. All right, that's why I want you guys to do the evaluation first. All right, we can't get an output of a negative number with absolute value. It's physically impossible. All right, so if you see absolute value of some function equal to a negative number, very easy answer. It's automatically no solution. You may also see it as what we call the empty set, which is just a circle with a line through it. So we call this empty set, which is just fancy math language for no solution. All right, so you could either draw that circle with a line through it, or you could just write out the word no solution. All right, turn over on the back real quick. So on the back is kind of just a basis of what we've been talking about with absolute value. All right. So with basic absolute value equations, if you take the absolute value of x and you set it equal to k, where k is greater than 0, so in other words, it's positive, your answer is going to be x is equal to k or x is equal to negative k. So in other words, let's say I had the absolute value of x is equal to 3. What two values could I plug in for x that if I evaluated would give me 3? -3 and 3. All right, that's why you get k, you get the positive version of it and the negative version of it. All right. Now, if you have the absolute value of x, you set it equal to 0. What's the only value of x that you can plug in? The absolute value that would give you 0. 0. All right. So x has to equal 0 because there's no negative positive version of 0. Now, if you do the absolute value of x, but it's less than 0, so it's a negative number, that's where you get the empty set or no solution. Because can you think of any number? If I did the absolute value of x is equal to -3, can you think of any value I can plug in for x that when I take the absolute value of it, it will give me -3? No, it's impossible. If we plug in 3, we get 3. If we plug in -3, we get 3. There's no possible way we can ever get -3. All right. So that's just some very basic things with absolute value equations. Now, on the other hand is the inequalities. So, inequalities. If you're given absolute value is greater than k or absolute value is greater than or equal to k. So, what did it do when we were doing greater than? It was going in opposite directions. Good. So that's how we would write it, using an or statement. It's either going to be greater than the positive version or less than the negative version. You could also write it like this using interval notation. Now, if we're looking at a number line, they use parentheses, but what else dictates a parenthesis? So in terms of open or closed circles, what would I use for a parenthesis? Open or closed? Open circle for parentheses, so you could do this as open circle, shaded in opposite directions. If it was a bracket, it'd be closed circle, shaded in opposite directions. So these are pretty much the exact same. The only difference is that these have equal to's underneath it and brackets instead of parentheses. Basically, the rule of thumb is that if it doesn't originally have an equal to, you can't just magically throw one in there. All right. If it does originally have an equal to, you've got to include that equal to. Now, on the opposite end, if the absolute value is less than k or less than or equal to k, so it's less than, what did it do if we're looking at the graph? Was it going in opposite directions or was it going in between?
In between.
It was going in between. So that's when we would write as a compound inequality. X is literally in between the two numbers. So like if we wrote it in interval notation, that's what it would look like. If you look at it from a graph, open circle, it's literally in between. Only difference here is that this becomes a closed circle in between. And again, only difference with the notation is that if you started without an equal to, you can't just magically put one in there. Leave it off. Do you have an equal to? Yes, you got to use an equal to. Now, do you need to remember all this? No. The biggest strategy that you can use is use Desmos to your advantage. At the beginning of the year, I told you, or semester, or whatever, at the beginning of the semester, I told you guys that about 80% of that EOC can be done in Desmos. This is a major help for that EOC. You can solve an equation using Desmos. That's about 30% of the exam right there. All right. So what I want you guys to do now, take out your packet. We're going to do a little bit more practice with this. So you guys can get a little bit more practice with Desmos. So take out your packet and let's go to page 30. Packet page 30. So the general basis of steps has not changed. All right. So we're going to do some more practice together. So on page 30, look at letter D. Now, we're going to do this entire thing in Desmos, but you're going to walk me through it. All right. So first off, we have an equation. How would I input this into Desmos? I don't just type it in verbatim. I got to do something. What did I do previously? So when we had 2x minus 3 is equal to 5, what were the two graphs that we had in Desmos? Y equals the left side of the equation, and then y equals what? 5, or the right side of the equation. That's exactly what you do. You take the left side of the equation. So your equal sign is your border. You take the left side of the equation, you type that into Desmos, set it equal to y. You take the right side of the equation, set it equal to y. Make sure, especially the right side, if it's a number, you gotta set that bad boy equal to y. All right? Or else it won't graph a line, it won't even register it as anything. And what are we looking for? How do we know where our answer is? What are we looking for? We're looking for the points of intersection. And remember, what value of the point do we only care about? What's the only part of that point that we care about? Do we want the x or do we want the y? Nope. X. So our answer is the x values of those points of intersection. The way you can remember that is, what do we always solve for when we solve an equation? We always solve for x. All right. Take a minute. Solve that equation using Desmos. If it's not a pretty number, let's say round to the nearest hundred, so 2 decimal places. I have to zoom out a little bit to see it. And so remember, your final answer, you write that as x is equal to the set of some number and some other number. Make sure you use the squiggle brackets. Thumbs up if you're ready. All right, so give me one of your solutions. Malachi, what's one value of x that you got? Say again? 2, good. What's the other one? Reagan. So we got 2 as one of them. What's the other one? Not quite. Someone help her out? Hunter, what you got? Negative 0.57. It was a really long, weird decimal. So, if I go back to Desmos, all right, y is equal to negative, what was it, negative 7x plus 5? Put the 2 on the outside. And y is equal to 18. May have had to go up a little bit. Find the points of intersection, which Desmos conveniently marks for you. You only care about the y value, so I told you guys to round this one to 2 decimal places, and then the other one's 2. How'd you guys do with that one? Pretty good? All right, try another one. Try on your own, so set up and everything, letter H. Replace the V with an X. All right, so replace that V with an X when you're putting it in Desmos. So if they ever use a different variable, whenever you bring it in Desmos, just go ahead and replace it with an X. Take a minute, do that one on your own. Take the answer, write it down, and beat around to the nearest hundredth again. That's okay. All right, thumbs up if you're ready. About 30 more seconds. All righty. Let's go with Autumn. What'd you get for one of your X values? Good. What's the other one, Briley? Right. So -6 is one of your X values, and then 7.33, and it does repeat, but we'll just leave it at that if we rounded, is your other answer. How do you guys feel about solving equations? All right, let's try some inequalities now. All right. So same process. You're still finding points of intersect because that gives you kind of your barriers. Remember those two lines where you're looking to see if they're on the other sides or in between them? Points of intersect give you those barriers. So let's try letter D on the next page. So the left side of the equation, you're still going to do y equals. It's the right side where it's going to be y is whatever inequality they have, so less than, this case, 24. All right. Now, remember, you still want the points of intersection as your barriers. All right. So points of intersection, you're still finding that, because that gives you your reference points. But then you got to ask yourself where the shading is. So where is the shading? Or where does the shading overlap the graph? Is it on either side of the barrier lines, or is it in between the two barrier lines? All right, give it a shot. Wink. All right, thumbs up if you're ready. Now, this one was a bit of a special case. All right, so I'll go ahead and move on just because it is a special case. So if you look at this one, I graphed the left side with an equals. That gives us the red part of the graph. And then I graph y equals less than 24, which is the blue part. So, is any part of that red line in the shading at all? Doesn't even intersect. No. So what's my answer? No. Right, no solution. So, yes. So, 0 is not an answer if there's nothing there. While we have learned that 0 means nothing, in math, 0 is still something. All right, no solution means at no point at any number on any number line will that graph cross the other graph. So for this one, you can either write no solution or you can just draw the empty set. All right, let's try one where you are going to get a solution. Try letter F. Let's give letter F a shot. So set it up the exact same way that I showed you guys to do. Give letter F a shot. So remember, you're either going to write it as it's going to be in between two x values, or it's going to be greater than one x value, smaller than the other x value. Find your reference points first. That's the point of intersection. So in other words, where is it initially in the graph? It should automatically mark it for you. So click on those points. Then ask yourself, if you drew vertical lines there, would the graph be between them or on opposite edges of them? So if it helps, put your pencil vertically along that point that you're looking at. Ask yourself, is the graph between them or on either side of them? Math is finished. Thumbs up if you've at least found your reference. All right. So let's talk about the inequality side of it together. All right, so I have here, I graphed the two functions. So I graphed the left side with the equals and then the right side using the inequality. Where are my two reference points? Anyone? So -1, and where's the other one? 5. So these are my two reference points. So in other words, if I drew a line, a vertical line going through these points, so here and here, I am asking myself where the red line is in the shading. All right. So let's look at -1 first. What part of the red graph is in the shading in relation to -1? Is the number smaller than -1 or bigger than -1? Smaller because it's on the left side of the line. All right. So how would I write that? X is less than or equal to -1. So we use the equal to because it originally had an equal to. What about for 5? Right, the red line is on the right side of the barrier line. All right. So X has to be greater than or equal to 5. Now, what special two-letter word do I need to put between these two? If they're going in opposite directions. An or. So because they're going in opposite directions, we have to include the word or, because remember, there's no number that fits both of these at the same time. All right, that makes both of these statements true at the same time. There's no number that is both less than or equal to -1 or and greater than or equal to 5. It doesn't exist. But as long as one of them is true, it's correct. Now, here's a pro tip. If you're having trouble kind of visualizing where the barrier lines are, as long as you figure out where x is equal to, which is the points of intersect. So x is equal to -1, x is equal to 5. You can literally plug those into Desmos so that you can see the barrier lines for real. So if I go beneath this, x is equal to -1 and x is equal to 5. And just like that, I have my two barrier lines inputted in Desmos for me. So now I can visualize it a bit better. Does that help a little bit if you do that? That's another strategy that you can do to see the barrier lines. All right, so you're asking yourself, okay, is the graph going to be between these two lines or on opposite sides of the lines? That's what you're asking yourself. Any questions? All right, let's do one more. I want you guys to try one more on your own, and then we'll call it a day. So for this one, the answer was x was less than or equal to -1, or x is greater than or equal to 5. So let's finish it up with, let's do letter A. So do letter A on your own. So remember, find your reference points first. Then you want your barrier lines. And remember, if you want to see your barrier lines, whatever your reference points are at, just set x equal to those two numbers. And I'll create your barrier lines when you want them.
Yeah, I was like, thank you. Exactly.
So guys, remember, once you get those points of intersect, my recommendation, make the two barrier lines and graph those in Desmos. So you can see exactly the graph is between them or on opposite sides of them. That'll help you when you're rewriting your inequalities. So if it's between, your inequality is going to look something like this. If it's not, your inequality, you're going to have two inequalities with a 4. All right? So between, it's going to look something like this with the numbers on either side, least to greatest. And then make sure you use the correct symbol. So if it's equal to, we'll have those equal to symbols. So the easy part is getting the two barrier numbers. The hard part is figuring out which form of inequality you have to write your answer in. All right, let's move on. What'd you guys get as your two barrier lines? What was x equal to? -10 and -8. Now, when you graphed it, was it going to be, was part of your b going to be between the two lines or on either side of them? It was between. So which form do I put it in? Top one or the bottom one? The top. So how would I write it? -10. It's less than or equal to x or n, whatever. I guess we can put n. It's less than or equal to -8. So whenever it no. So whenever you do it between, you always write in numerical order. All right. Now, pro tip for opposite ends. You're doing opposite sides. The less than part typically goes with the smaller number. The greater than goes with the bigger number. All right. That's kind of a way to think about it. Any questions on this? All right. So for the rest of class, you guys got a solid 20 minutes. There's a new delta math assigned to you. It's called 1.5 to 1.6. You only need to do the sections right now that say absolute value. All right. The other sections are piecewise, so which we'll learn tomorrow. I gotta change
Where is it? Run that?